This video is calculation of frictional forces of a snowboarder. Now let's read the problem. The snowboarder glides down a slope that is inclined at theta is equal to 13 degrees to the horizontal. Now this is the slope of the inclined plane or inclined ground at theta is equal to 13 degrees. The coefficient of kinetic friction between the board and the snow, mu k, is equal to 0.2. What is the acceleration of the boarder? Now, we are given with a snowboarder who accelerates downwards. Now, the angle of the slope of the inclined ground is 30 degrees. If we're going to bisect the snowboarder and consider the external forces acting on the snowboarder, this gives us the weight, okay? The y components of the weights or the inclined y components of the weights. If we're going to consider our analysis with the inclined plane, this is the y components of the weights of the snowboarder as mg cosine 13 degrees. If we're going to apply the trigonometry, and the x components or inclined x components of the weight of this snowboarder gives us mg sine of 13 degrees. Now the normal force, okay, is calculated as the opposite of the vertical or inclined vertical axis of the weights, and our frictional force, kinetic frictional force here, is opposite with the direction of the weight of the man at the inclined x-axis. Now, if we're going to consider the summation of forces, f of x now with the inclined would be equal to the mass times the acceleration. This gives us for forces moving towards our left is positive and towards our right is negative. Okay. Now, mg sine theta minus the kinetic coefficient of friction multiplied with the normal force equal to the mass times the acceleration. Now, this is our first unknown equation. Now, for our second equation, we're going to establish our balances of forces with the inclined vertical axis. So summation of Fy is equal to mass times the acceleration with the vertical axis. Okay. This is for upwards positive, downwards negative, n minus mg cosine theta is equal to mass times 0. Why is it 0? So this is because of no acceleration moving upwards or downwards direction with respect to the inclined plane. This gives us n is equal to mass times gravity cosine of theta. This is our second equation. Okay. Now remember, if we're going to manipulate all the equations and substitute first equation with the second equation or the second equation with the first equation, say for example, we have ax is equal to mg sine of theta minus mu k multiplied with the normal force mg cosine theta all over the mass, and we're going to substitute the first equation with the simplified or the second equation with the simplified first equation gives us the following as ax is equal to gravity times sine of theta minus the coefficient of friction times cosine of theta. Now, if we're going to substitute our angles, this gives us the following. The gravity at 9.8 times sine 13 degrees minus our kinetic coefficient for friction at 0.52 cosine of our angle 13 degrees, or this gives us 0.29 meters per second squared for this problem.